Complex numbers z1 and z2 are defined as z1 is 1 plus I and z2 is 3 minus 4I. So we want z1 plus z2, so that's 1 plus I plus 3 minus 4I. So adding the real parts gives us 4, adding the imaginary parts gives us minus 3I. Here we have the modulus of z2 bar. Well, that's going to be exactly the same as the modulus of z2, and that's just Pythagoras' theorem. So that's going to be 3 squared plus 4 squared, which we should know is 5. Now we want to multiply them. So that's 1 plus I, and we're multiplying that by 3 minus 4I. So we just expand the brackets. So that's 3, add 3I, minus 4I, take away 4I squared. Now I squared is negative 1, so we're taking away negative 4, which is the same as adding 4, so that's going to give us 7. Take away I. Now we have z1 squared plus z2 to the negative 1. So z1 squared is 1 plus I, 1 plus I. z2 to the negative 1 is 1 over 3 minus 4I. Expanding gives us 1 plus I plus I plus I squared. And then here we need to realize the denominator, and we do that by multiplying top and bottom by the conjugate. So, like so. Now this is 1, take away 1 here, so that disappears, so we just get 2I. And then here we've got 3 plus 4I over 9 add 16, which is 25. So we've got 2I plus 3 over 25 plus 4 over 25I. 2I, of course, is 50 over 25I. So that's going to be 3 over 25 add 54 over 25I. The complex numbers z3 and z4 are defined as z3 is negative 4 take 4I and z4 is equal to 2 plus 5I. We want to sketch z3 and z3 bar on the set of axes below. So z3 is negative 4 take away 4I. So that would put it just here. Now it's normal to represent complex numbers as vectors. z3 bar must be 4, negative 4, add 4I. Remember, the conjugate has the same real part, but you change the sign on the imaginary part. So that's actually going to be just here. Like so. So this one here is z3 bar. By representing z3 and z4 as vectors, demonstrate z3 plus z4 on the argon diagram below. So z3 is negative 4, negative 4, so that's down here. Like so. So this one is z3. And then z4 is 2 plus 5I. 1, 2, 3, 4, 5. So that's just going to go from here to here. So it's just vector addition. So that's z4. And then the third side of that would be our result. So that one there would be Z3 add Z4.